Hi everyone, this is Oscar Kokwajman, a student from University of Cape Coast, Geography and Regional Planning. I bring to you research design. When we look at correlational research design. When we talk about correlational research design, people would like to associate some variable to the other. For instance, would like to associate cigarettes or smoking to heart disease as well as drinking to heart disease. So you just want to know whether these two variables have some relationship. You want to know whether there is a strong or there is a weak or there is a negative or positive correlation or negative relationship between them. So they want to know whether as someone keeps on taking alcohol, will the person has the propensity or the probability of getting heart diseases increase, or is it high or low? So this is the purpose of the research design. Correlational design is to discover and to establish the existence of a relationship, association, or interdependency between two or more aspects of a situation or a variable. A correlational research is aimed at determining the nature, degree, and direction of the relationship between variables, or using the relationship to make prediction. So as I said, they want to know if, for instance, drinking or smoking, the relation it has with heart disease. So they want to know whether there is strong relationship or weak relationship, or whether there is a negative or positive. When you talk about negative, you want to know whether as one increases, the other one decreases. When you are talking about positive, you want to know whether as one increases, the other one too is likely to increase or not. It describes and assesses the magnitude and the degree of an existing relationship between two or more continuous or quantitative variables with interval or ratio types of measurement, or discrete variables with ordinal or nominal type of measurement. It also involves predicting one or more continuous quantitative dependent variable from one or more continuous quantitative dependent variable. For instance, we can examine a study like mergers and acquisition of firms and their financial performance. So this stage, you want to know as firms emerge together or as firms acquire others, and how it affects their financial performance. We can also look at occupational stress management and employee performance to know how employees manage their stress and how it affects their performance at the workplace. We also like to look at the relationship between smoking or drinking and heart disease. Correlational research comprises of collecting data to determine whether and to what extent a relationship exists between two or more variables. Correlational research uses numerical data to explore relationship between two or more variables. It purpose on the degree, or it aims at examining the degree of relationship that exists or expressed by the Pearson coefficient of the correlation. We use the Pearson R correlation coefficient to determine the degree of relationship between two or more variables. We can also use Spearman correlation. This is when your data is not a continuous variable or is not normally distributed. So you would like to use Spearman when you are using ordinal or discrete variables. You can also use the biserial correlation when you have to compare a nominal data with a continuous variable. You can look at that one. We are looking at the basic types of correlation design. We have the explanatory and prediction design. When you look at the Explanation design, what you are trying to do is that it involves a study that tries to compare gender differences in employee motivation against extension employees in plantation farm. What you are trying to do is that this type of correlational study explain what we mean by, or explain the relationship between those variables. Whilst the other one, that's the prediction correlation design, it only predicts, it only assume, it only forecast the relationship between two or more variables. Looking at the advantages of the correlational design, consider it examines the degree of association or relationship between two or more variables. It can collect much information from many subjects at one particular instant or time. It can study a wide range of variables and their interrelationship. It can also study variables that are not easily produced in the laboratory, in a sense that it can study variables or phenomena either naturally or at the laboratory. It can also be cost effective and quick, as it can help you to study a wide range of variables within a particular instance. It can be used both in the natural and also at the laboratory setting, as I've already said. However, there are some disadvantages of this design. For instance, this design fails to show us the causal or the cause and the effect relationship between the variables. It can only tell you that maybe the higher you take alcohol, the higher the probability of you getting heart disease. But this design cannot categorically and emphatically state the cause and effect or the causal relationship and be bold enough to tell you that yes, drinking or smoking is the cause of heart disease or influence heart disease. But I can only tell or assume or predict that as someone takes in more alcohol or smoke, the person is at a higher risk of getting heart disease. It cannot control or disregard confounding variables when present. It can compare aggregate groups and not individuals in exposure and disease occurrence. They provide little control over extraneous variables as compared to the experimental design. They do not show the reason for the relationship. It can only tell us the degree of association or the relationship between variable A and B. It can only tell you that, for instance, the higher you take in alcohol or smoke, the higher the probability of you getting heart disease. But it can't tell you the reason why when you smoke you get a heart disease. Thank you. Subscribe to our channel to get more updates on research design and other methodological issues and quantitative data analysis. Thank you.